Hi, my name is Bob Beechell. Now in this first of two videos I'm going to be looking at what's called the Tidyverse in R. Now this is a new set of integrated functions that's becoming a very popular way of doing work in R and particularly for data science. So here we are in RStudio, and the first thing I'm going to do is to load up the Tidyverse package. Now obviously if you don't have this installed, you'll need to install it in the usual way from the Tools menu and Install Packages. Simply type in Tidyverse, search for Tidyverse. Make sure that you install dependencies so that all the other packages it requires are installed as well. So let's use the library command to to load up the package. And as you can see, it tells you that it's attached to various other packages that it requires. It's also replaced the built-in filter and lag commands with its own versions. Now, the Tidyverse involves a data set which is called a tibble, a rather strange name, which is basically a data frame, but has additional features and is geared more towards using the Tidyverse functions. Now you can create a tibble using the tibble function, which is equivalent to the data.frame function. So to give you an example here, I'm going to create a couple of vectors. Firstly a numeric vector here, and then a character vector. So two variables, in other words, x and y, and then I'll put those together into a tibble by using the tibble function. And as you can see, the syntax is very straightforward, so I'm going to put this into the tb object, tibble, and then in brackets, separated by commas, the variables that you want to put in. So running that, we get the tibble here. Notice it's a tibble data frame. It's a data frame, but of this particular tibble type. So showing this on the console, as you can see, it says it's a tibble. It tells you how many rows, how many cases, and times how many variables. So we've got two variables here, 5 cases. Notice it also tells you here the type of data in each one, integer and character. Now if you want to access each particular variable, each particular vector, there are two ways to do it. You can use the $, just like, which is similar of course what you do with lists. So here I put $x, that will access the x variable, x vector. So as you can see there, we get that. It's a typical numeric vector. Obviously, if I wanted to use that, I'd store the result here into another variable. So here's accessing the y variable in the same way. So that's one way of doing it. The other way is to use double square brackets and use the index of the variable. Now, they start from 1, of course, in R rather than 0. So this is column number 1, column number 2. So here I'm accessing this y variable here in the number 2 variable. As you can see, it returns that variable. Now obviously if you want to access an individual item, then you would access first the variable, the column, and then use an index for the particular item. So if I want to access the third item here in the y variable, which is Jim, then as you can see it's $y to access that, and then in brackets, single brackets this time, because we're not accessing a column, accessing a single item, number 3. So that should give me Jim. And there it is. So now that we've got the idea of a tibble, let's look at how to import some actual data into a tibble. Now there are two ways in which you can do this. You can read the dataset using the standard read.csv command, I'm assuming here that we're going to read the data from a CSV file, which is often the best way. And that will read it into a standard data frame. You can then turn that into a tibble by using the as_tibble function. But a better way is simply to use the Tidyverse version of read CSV, which is read_CSV. This reads the data directly into a tibble. And just notice a difference here that if your data set, if your CSV file has variable names in the first row, which you normally want to have, you have to, in the standard function read.csv, you have to indicate that by header equals true. In the read_CSV, you don't. It assumes that's the case. So let me read this file in. Now, of course, as you can see, all you need to do there is to put the file name. Now here it's assumed, of course, that the file is in your working directory. So all I need is the file name in inverted commas. If it's not, of course, then you would need to put the full path to the file. So let's read this in. And it tells us that it's a file containing 3 variables. One, the gender and site contain characters, and the third one contains numeric data, which it's put into a vector containing double data. Now, notice that the variables here, gender and site, which contain character data, have just been read into character vectors. Now, in fact, that's different from what would happen with the conventional read.csv function. That would read in character data, character variables, and then convert those vectors to those variables to be factors, rather than leave them as characters. Now, if you want to do that, if you want to convert these character vectors into factors, you can do that, and I'll show you how to do that later on. But in fact, in the Tidyverse, it's not really necessary to do that, which is why the read_CSV function doesn't do it. So let's now have a look at this tibble. And there we are. We have a tibble with 20 rows, 20 cases of 3 variables. There, as you can see, are the 2 character vectors, gender and site. And there's the numeric vector. Now, of course, as we've seen, to access particular variables, you can use the dollar notation, or you can use the double square brackets. Here, using the dollar notation, I can access the gender vector, the gender variable. That returns that, which of course I could store if I wanted to use it. Now let's look at subsetting, because often, of course, when you have a data set, particularly a very large data set, you only want to look at a specific subset of that data, and you need to filter the data by, via some criterion. Now, the function to do that in Tidyverse has an appropriate name. It's called filter, and the syntax is quite straightforward. After the word filter in brackets, you first of all indicate the tibble name, comma, and then the condition which determines the subsetting. So here, as you can see, I'm going to focus simply on the cases here where gender is male. So I'm just looking at the male ones here. As you can see, the syntax is straightforward. The variable gender, double equal sign, of course, here, not a single one, and then the thing that you want to restrict it to. So here we get just the males. Now notice that this function, like all the other functions I'll be looking at, returns a tibble. So obviously, if you wanted to make use of this subset, you'd be best storing it into, assigning it to a particular variable, which you can then use later on. I haven't done that here because I'm simply illustrating the functions themselves. Now, of course, you can have more complicated conditions by using Boolean operators, and, or, and not. So here, I'm going to simply focus on those cases where the gender is female and the site is Facebook. You can either use the and symbol, which is here, this ampersand, or simply use a comma in this case. So as you see, this should return a tibble where it's just females using Facebook. Well, there we are, there's 3 of them. Here I'm using the OR operator, which is this vertical line. So this is going to return those values where the site is Twitter or Pinterest, but not Facebook. Oh yeah, Twitter or Pinterest. And finally another example here where I'm just going to focus on those cases where the gender is male, and in this case I'm using the AND operator. The site is not equal to Pinterest. This of course is how you indicate not with the exclamation mark. That's fairly standard. So this will only return those cases where they're male and they're not using in Pinterest. So it'll either be Twitter or Facebook. And there we are. Male and just Twitter or Facebook. So very easy to subset using the filter command. Another command you can use is arrange. Now this will, as the name implies, arrange the data, the cases in your dataset in either ascending or descending order based on one of the variables. So here, let's look at an example here. I'm going to reorder the dataset by gender. So let's look at that. As you can see, it's now been reordered such that it's in ascending order of gender, female first and then male. Now if you want to arrange in descending order, then you simply have to use DESC here as an option. So again, you can see the command arrange, then the name of the tibble, comma, and in this case DESC in brackets site. So in other words, I'm going to reorder the data here via the site variable in descending order. So it should start with Twitter and then Pinterest and then Facebook. So let's have a look at that. And there we are. Now you might want to, of course, arrange in via one variable and then within that arrange by another variable. So that's easy enough to do by using this syntax here. So this says I'm going to arrange the data, reorder the data first by site and then within site by gender. And there you can see it's arranged first of all by site in ascending order, and then within each site it's arranged by gender, again in ascending order. Obviously if I wanted descending, I'd use the DESC option here. And finally, of course, you not only can arrange via the category variables here, but also by a numeric variable. So again here I'm going to arrange the data via usage in ascending order, and there you have it. Remember, of course, this function here is not actually rearranging the data in practic.tb in your actual tibble. It's returning a new tibble. So if you wanted to use the data in this particular order, then you'd need to store this the return value, the tibble that's returned by this function, in a new variable. Now, another thing that you may want to do is to only use one or more of the actual columns of data, a subsetting via columns rather than by cases. For that, the command is select, and again it's very straightforward to use. Select, in brackets, the tibble, and then comma, and then what you want, the variables that you want. So here I'm just going to use the gender variable. Notice the difference here from just selecting that variable using the dollar notation. That returned the actual vector. This returns a tibble. Now if I want more than one variable, all I have to do is to list them here, separated by commas. So this will return the gender and the usage variables only as a separate tibble. like that. If you had I've only got 3 variables in this small data set, of course, but if you had 10, 20 or more, you might want to return a subset of a set of adjacent columns. You can do that using a colon. So here I'm going to return gender to site, read the colon as to, so that will return all the columns from gender up to site inclusive. In my case, that's only going to give me just the first 2 columns again, like that. But obviously if I had a lot more columns, it would be a quicker way than putting them all separately separated by commas. And finally, you might want to return the variables accepting some. So here, as you can see, I think you can see what this is going to do. This is going to return all the columns, excluding those between gender and site, inclusive. So of course, in terms of my simple data set here, that should simply return the usage variable. And there we are. So notice here, this is returning a tibble, not a column vector or column vectors. So again, if you want to use this subset of columns, store it in a particular variable. Now, one final thing here we can look at is how to rename variables. If you wanted to rename one or more of the variables, then the function to use is called rename, quite obviously. And you can see the syntax here. So it's here I'm going to rename the usage HPW variable to simply usage. And notice the syntax here, you put the new name first, equals, and then the old name, not the other way around. Now of course this, like all the other functions, does not actually rename the variable in your tibble. It returns a tibble, a new tibble, which you would need to store if you want to use it. So that's what I've actually done here this time. I've actually, as you can see, assigned this tibble that's been returned into a new tibble called new pract b. So let's run that command. Now of course it hasn't printed it because I've actually stored it in this new variable. So let's have a look at this. And there you can see we have my data set, but now with this column renamed. And to show that in fact it doesn't change the original tibble, it returns a new one, let me just display pract_tb again. And as you can see, that of course still has the original name of that variable.